Focus now.
Okay, so I'm redoing it for a reason because it gets too much for your brain at one time. And this is crucial for the cubic graph. Because in the cubic graph, you're going to work with putting it equal to 0, the fx, meaning I'm getting my x-intercepts. So this I'm going to use in finding the x-intercepts. Not necessarily always this remainder and factor theorem factorization, which I call Batman, or the synthetic division. Not necessarily, because it could be something like this. And then you didn't need to factorize with this new technique that I'm teaching you. You could have then factorized by taking out a common x. And then there would be a quadratic expression which you can factorize yourself, like always. Are you with me? But if you need it, you need to know this technique. So this is the sixth type of factor. You've got common factor, difference of squares, trinomial, grouping, sum and difference of cubes. Please don't forget about the sum and difference of cubes. If it's there, it'll be somewhere for 2 marks, but it can be asked. And then we need another type, which is this Batman story. I'm trying to factorize. So if I've got the expression equal to 0, trying to find x-intercepts, I need to factorize this. It's always been the case. Linear, get x alone. Exponential, get the basis the same. Or we went to logs, right? Exponential. If it's more than quadratic, getting to power 3, power 4, etc., this is the only answer. You're going to use the remainder and factor theorem. The technique is called synthetic division, or name just says Batman, it's just me that calls it that. And the technique is the following. You use the coefficients of every one of them. So it'll be 1, -1, -5, -3. We make like a big block there. And then the technique is the following. Remember, this is our spy language. It's only us and Batman in the Batcave that knows about this. We know what's going on there and how to read from it. So the first thing is, here I will write exactly what's there, which is 1. Bring it down. Then I need to go find out what to write here. And that I find using my calculator. Whether it's the new calculator or the old calculator, you're going to function notation. Because I'm not asking you to do that, I just see it in your sketch, or in your sum. You know what you did with your calculator. So if you go to your calculator and you go to functions, and you go to fx and you read in with your shift alpha to make that red x, and you read in x to the 3 minus x to the 2 minus 5x minus 3, and then you would like to get an answer of 0. Now I need to teach you that, because that's actually the remainder and factor theorem, which doesn't get asked anymore, but that is the remainder and factor theorem. The moment that you can put some x in here so that it gives you an answer of 0, you have found a factor. If you get a remainder of 0, you have found a factor. That's what the whole story is about. So originally, long time ago, you had to go and actually do the substitution and fill in there a 1 and see it doesn't work. Fill in there a -1, and we saw yesterday it does work. If you put -1 to the 3, -1 in there, with a minus there, everything, it gives you an answer of 0. That tells me if -1 works, x plus 1 is the factor. This is what I'm teaching you. All I need you to write here is -1. So originally, you had to go test 1 and -1, 2 and -2, 3 and -3, until you got one that works. So the arrangement was, we never gave you like a 6 as a factor, the only factor, and you had to go search through all of them. But now that you go to your calculator, you go to the functions, and you ask it to do step 1 in the functions, and start off with -3 and end off with +3, and the one that would work for you there was 3 and -1. How do you know? Because in those two tables, you'll have, if x is -1, the y value works out to 0. That's what I'm looking for. If x is 3, it worked out to 0 as well. Now you could choose any which one of those two. Okay? But the thing, and the new calculator is so much better, because also with the new calculator, you just fill in a and b and c and d. Ax to the 3, bx squared cx plus d, and you fill that into your calculator under A, B, C, and D. It goes on to the next screen. Then, if you ask it equals, it does your graph for you, just like with the quadratic one, which means you can use it in quadratic for the parabolas. Because those x values that it gives you there, x1 is and x2 is the x-intercepts. But the thing with this particular sum, it only gave you the answers of x is equal to -1, and it gave you x is equal to 3, if I'm remembering correctly from yesterday. That's what your calculator gives you. So you need some sort of a technique to get there. So either you're going to have to do it yourself and fill in a 1 and fill in a -1 and fill in a 2 and fill in a -2 until you get the answer of 0. Once you got that answer, you know what your factor is. Then you need to factorize. The factorization is the following, and you must focus, my children. So first thing is you're going to multiply and get your answer and put it there, which is equal to -1. -1 times 1 is -1. Then you add and get your answer here, that gives you -2. Again, the same procedure. You're going to multiply -1 and -2 and get +2. Then you will add, and when you add, you get -3. Then you will multiply again and get +3. And when you add, this is always my technique to remind me that I've done it right. Since I knew that it was a factor, after checking that it's going to be an answer of 0, this should be a 0. Otherwise, your technique was wrong. You did it wrong. What does this represent now? Because once you know it, this is the factorization part. This represents in Batman Cave language that the first bracket should be x plus 1 to get me an answer of -1. The second bracket will be a trinomial answer with an x square and an x and a number without an x, and the coefficients are 1, which you don't have to write, -2 and -3, and you have just factorized. Getting a linear and a quadratic factor. Can you then further factorize? Because that's a quadratic trinomial. And it's not always one that has factors. It could even be one that has to be done with a formula. Could be. Because remember, I'm looking for a cubic graph, and in the back of your mind, you know that it could have 1, 2, 3 x-intercepts. This, my calculator told me that there's only 2, so I know that one of these x-intercepts is also going to be a turning point. So if it's one of the x-intercepts is also a turning point, it's going to be something like that. So you only have 2 x-intercepts, and one of them is also a turning point. But looking at it like this, I don't know. With the new calculator, it also tells you the maximum at the point, and they give it to you the correct one. So in other words, what I'm saying to you is the new calculator helps everywhere. Okay, so for the next part, I need to go factorize this. How? Again with the new calculator or with your old brain, factorizing to know that it's x minus 3 and x plus 1. What am I busy doing here? Factorize. It is equal to 0. I'm just putting the 0 on the left-hand side now. So after factorizing that, I'm now solving for x. Factorize with a huge new thing, and then out of that get my factors so that I can say the answers are x is equal to -1, but there's 2 of them. And that means that this is also my turning point. Now if you went to your calculator, the new calculator, it will also tell you that there's a maximum or a minimum at this point, and even give you the answer for the y value as well. So you're going to have to know that for turning points as well. Well, the y value here would be 0, right? Because it's x-intercepts. -1, 0, and 3 and 0. But the one with the -1 is also going to be a turning point, because there's only 2 of them. You have to realize that you can have 3, you can have 2, and you can even just have 1. So if this moves up a little bit more, it's only going to cut once through the x-axis. So Batman is for factorizing. Factorizing something with higher powers than square, because square ones you would do them the old way, either with a formula or with your own factorization. But the moment it gets to more than that, power 4, power 5, this is the way to do it. Find a factor, do the synthetic division, and then if it was a power 4 and a 5, then this would be power 3 and 2. Okay, if this was power 4, then this would be a power 3. Then you do it again. This is not our level, we won't do that. So it could be that this was a linear one, but this was a power 3 one. Then you'd have to do it again and again until everything's factorized. That's above and beyond what we require of you. Just saying that if it's more than power 2, the technique is the remainder factor theorem, or the factorizing method that I showed you with synthetic division. Is it going to become easy? The more you practice, the easier it will get. But you need to practice this, because this is wildly different than anything else that you've ever done. Okay, so now let's go to another question. Okay, our next example. First of all, I would like to get the x-intercept, so that's why I'm going to put y equal to 0. Then I need some new technique, because this is what should be going through your thoughts. I need to factorize that. And how do I factorize the power 3 thing? Batman. Then you use the coefficients 1, minus 1, minus 10, and minus 8. Please don't forget the negatives as well. And then we're searching. Now I've already written the answer there for you, but where does it come from? So you go to your calculator, whichever one you've got, and you use the table method to go and find with those values, and you're typing in your function with alpha, x to the 3 minus x to the 2, what, and then you're saying step. Now I've actually changed my mind. I think it's safer for you to say it goes from it's step 1, but it starts at negative, say 5. Negative 5 up to 5. Because then you would also get this one answer that I know from the new calculator. So the wider you make it, and I mean your calculator is big, but the main thing is you must be looking for an answer of 0. So you're going to have the table of which you're saying go from minus 5, minus 4, minus 3, minus 2, minus up to, and then you'll see that the ones that work, that give you a 0 answer, are 4 and negative 1 and negative 2. Now this is such easy marks then for me. I already know the answer. I must just make the body count. Okay. So this should then be x minus 4, x plus 1, x plus 2 equal to 0. So if I only write that and this, full marks. You have to show them a technique. So yes, we're cooking it right, but you have to show them the technique, which is the synthetic division. So you can now choose which one of the lot would you like to use there. I've already said let's use minus 1. Meaning x plus 1 is a factor. How I've got that, which calculator, or even by taking my own brain and saying, let's substitute for 1, get an answer, it's not 0. Let's substitute for minus 1, it gave me 0. So then I got 1. Because that was the technique old school years ago when they didn't use the calculators. So you try 1, minus 1. You try 2, minus 2. You try 3, minus 3. So that would be the second one that you would get, and that would be the third one that you would get, and then you have done 20 minutes of substitution. It's too long. Okay, so now that I've got the answer, let's make sure that it does get you here. How does synthetic division then work? First thing you do is you bring down that number, whatever it is. Unfortunately, it's 1 again, and very often it is 1. But whatever's there, you bring down. Then we are multiplying and getting negative 1, which comes there. Then we add and get negative 2. We multiply and get 2 plus 2. Add and get negative 8. Then we time and get 8. Positive 8, and the answer is 0. Which I'm reminding myself, I'm shocked. What does it represent? Like the James Bond technique of writing, my Batman cave wording says that the first bracket should be x plus 1. The second bracket is the trinomial here. And I'm telling you that there is going to be some that maybe have a 0 here. Okay? If there's a 0 here, it would have just been x squared minus 8. And then your sum carries on. So we've got
X squared minus 2x minus 8.
okay, whether it's at the back or 0 at the front, doesn't matter. This is my linear factor, and this is my quadratic factor. And how do you factorize a quadratic factor? Same way that you've always done it. Now I've written it in the wrong order, so with your James Bond technique, Beckman and James Bond go like this, you see. So x minus 4 and x plus 2 will work. With your James Bond technique or your calculator, doesn't matter. And then I'll get my answers of, this is just in another order. X is negative 1, x is 4, x is negative 2. Meaning I'm on my way, well on my way to draw a cubic graph. But all I know at this stage is that the x-intercepts are negative 2, negative 1, and 4, and I don't have enough information yet. Okay, one thing that I did tell you is that the shape, if A is positive, should be first increase. First increase. So somewhere before this, it should have been increasing. So I'm just saying, can we make an estimation what the sum should look like? So it should go through there, back through there, and back through there. And it has to be increasing. But somewhere between these two, it's got to have a turning point. And somewhere here, go through the y-intercept. And somewhere turn and go back into that. Now guys, if that's the only thing you did in an exam, you had marks. Because you have the shape, it's just horrible. But okay? You have the shape, you have the x-intercept, you've got marks.
Oh my God.
So all I wanted this example to be is to see if you understand and grasp the technique of synthetic division. But it's actually all about factorizing. Our sixth type of factorizing is done by the James Bond, no. Beckman, no. Synthetic division. Are you with me?
Yes.
This technique helps you to factorize. Once you factorized, you have now gotten the
Factor.
x-intercepts. Because you put it y equal to
0.
0. So these are your
X-intercepts.
x-intercepts. So far so good. If I want to sketch this thing, I should have started off and said, first of all, the shape. And the shape I told you to write down was, because of that is equal to, did I tell you to write it down? I think I did it in the other class. So if this A value is positive, you're going to have an increasing, decreasing, increasing graph. If that A is negative, what is this A? It's 1, right? Positive. So it should look like this one. If it's negative though, it's going to first decrease, then increase, then decrease again. Facts. Just like the smiley face and the frowny face of parabolas, this is something that you must know for fact. So far I know the shape is going to look like this. And I know that my x-intercepts are -2, -1, and 4. And if you did something like that in an exam, you'd have marks. Because you've got the shape, you've got your x-intercepts. You won't have full marks because you haven't done everything. What do I need? Turning points and?
Y-intercept.
The y-intercept. Okay, now the y-intercept I generally do first. It's the easiest one. Generally first the shape. The y-intercept is -8. That d part of ax to the 3bx squared cx plus d. Because for a y-intercept, what do? X equal to 0. 0, 0, 0. Answer is? Or you could say even d if you want to remember it like that, or the original way that it's written. So if that's your y-intercept, we are still only needing. So the y-intercept of -8, I'm guessing, is about here somewhere. But I'm desperately needing the turning points, and this is the only reason why you didn't do this in grade 11. Because you haven't done calculus yet. So for the turning point, you need to know something very specific. You're going to do calculus, you're going to do derivative, But you need to know that the derivative is the gradient. So if I do the derivative, I'm going to get to the gradient. In every single point of the infinitely many points that there are on this graph, there will be a positive gradient up to the turning point. Then there will be a negative gradient. From point to point, it's going to change. And then it's going to be in the turning point, and then the gradient is going to be positive again. But the gradient is definitely not constant, like in a straight line. It changes from point to point. Are you with me? Here's the thing to catch. If I want to get the turning point, what's the gradient?
0.
Oh, yeah.
Positive, positive, less positive, less positive, 0. Negative, negative, more negative, less, but 0. Positive, 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 changing. But the gradient is equal to, for knowing that, you're going to get a mark. That you get the turning point for knowing that in the turning point the gradient is 0. And how do I get gradient? Derivative. So back to our old school quick method of factorization. Back to the front. You're going to say 3x squared, right? And then minus 2x. Help. Minus 10. That's 0, right? Why do I put it equal to 0? Because this is gradient and the gradient is 0 in the turning point. This is gradient. This is the gradient. Anyway, in the point where x is 2, I'll get a gradient. In the point where x is 3, I'll get a gradient. In the point where x is 17, I'll get a gradient. How? Substituting that x with a 17 will tell you what the gradient is in the point where x is 17. And you'll find, wherever it is, there's going to be a positive gradient of some sorts. So you can find the gradient at any point, but it will differ from point to point. But finding the turning point, that's where the gradient is equal to, it must make sense to you. Okay, now what do I do with that sum? James Bond method. Right, 1 times 3, and for 10 I've got 2 times 5. Okay, it's not going to work. Or 1 times 3 and 5 times 2. It's not going to work either. So if I think this is going to be with a formula. So, oh no, formula. Can it be formula?
Yes.
Okay, how's the formula going to be?
Negative b. That time is plus minus b, I think.
X.
X is equals to minus b plus
Where do you find
minus
this?
b squared minus 4ac over 2a.
Where do you find this?
In your formula
Formula
sheet.
sheet. First thing that's on the formula sheet. Don't forget it, check it. But you know, with the new calculator, you just need to put into your calculator under equations
So this
A, B, C, and your answers would be, what are they? Please? Answers? Answers?
Minus 1 plus square root 31 over 3.
Over? And the other one should be negative. Okay. What does that tell me if I'm working with my new calculator? That I should have used the formula. And if you did use the formula, is this okay? I need to see you do it. Although the calculator gives me the answer, I need to see you going minus of minus 2 for the B part. And then B is minus 2 squared. Oops, I got 2 little space here. Minus 4a is 3. And C is negative 10. All over 2 times 1, which is a 3. And this will be my answer. But I need to sketch this. So where's this point? So rather give me decimals, please. Give me the decimal answers.
For the second one is minus 1.
For the first one.
Second one.
Yeah, minus 1.
Minus 1, comma 5, 2.
And we always round off to 2 decimals because we've been brainwashed in that, right? And the other one, please.
2, comma 1.
Okay, so what did we just find out here? The x value of the turning point. But I can't just have an x. I need the corresponding y. So you substitute back into the original sum so that your y would be, and I'm going to pause quickly so that we can get the answers there, please. Alright, so we needed to take this x value that we just received of the turning point and take this x and fill it right back into the original sum and work out what the corresponding y was. So what are the turning points? Turning point is 2,19 and negative 24,19. How horrible is that? Are the sums usually looking like this? Well, it's not to say. They can have nice whole number answers like minus 3,5. That's perfect. But it doesn't matter if it's a decimal or not. So the other turning point would be x is equal to negative 1,52. Please be careful with these commas and semicolons, okay, that you can see where the point is. And this would be 1,38. So guys, we are ready to sketch our first cubic graph. So what's it going to look like?
That's
Knowing a few things. Okay, now the examiner says time's up, hang in your paper. You're thinking, no, I'm almost there. What do?
just draw the shape.
Just draw the shape. You need the y-intercept is easy, negative 8, are you with me? And you know that there's this shape. If you can squeeze another 2 seconds out of them, then it'll mean that you've got your x-intercepts of, what was it? Negative 2 and negative 1, right? Am I right? Can't remember? On the other page. And then it was 4. Those are my x-intercepts. Now I also have turning points. So you've got to have a technique. Different people have different techniques. Because you need to know that those are intercepts. And now I'm going to do the turning points. So my turning points, my technique, my habit, is to put them there with a little cross. So 2,19 on the x is somewhere here, right? And negative 24, it's going to be somewhere down here, way past this. So it's 2,19 and negative 24,19. Are you with me? It's not accurate. It's a sketch graph. But I know that it's going to turn there. I already know in my back of my mind I've got to have something like this, right? So if there was no time, I would go boom. I don't know where the turning points are, and there I go. Are you with me? So then the other turning point, I have a good estimation, should be in between here. And it is at negative 1,52, aha, in between them. It's got to be. Not exactly halfway though. Remember, in a parabola, if you knew that this is 1 and this is 5, what's your turning point? This is 1 and this is 5. Your turning point should be at 3. Halfway. 3. This is not the case with a cubic graph. It's not symmetrical every time it turns. Okay, it's a little bit skewed. Okay, so that's why it's negative 1,52 and positive 1,8, so it's not very far up. So negative 1,52 and 1,38. There's my turning point. I'm making a cross for myself, so I know that that's where it crosses, where it's turning point. So it's got to come from somewhere here, going through every single point that I have there. And they do give a mark for your shape, and then also that it looks kind of almost nice. So little mistake like that won't be a big problem, but you try your best to make it a nice smooth curve. And that was your first cubic graph, and I've done 3 pages full of it. And then it was called F, right? Okay, so the only new thing that you were taught from grade 11, no, not the only, but the thing that you needed from calculus was the turning point. This little piece here, for differentiation, you couldn't have done it without it. So you needed differentiation to be able to get the turning point. Happy on that? Okay, so then, and that's not the only new thing, because you also needed to do factorization. Could we have taught you Batman in grade 11?
No.
Yeah, why not? It's weird, and it takes some time, and you didn't need it until you got to cubic graphs. So that's why it's here. Not because you need calculus, You need some new factorization, and that's why you're taught this. So in the cubic graph, you need to know how to do synthetic division for the x-intercepts. If needed, it might not be needed. And then you need always to know that this is going to be worth 1 or 2 marks. To do the derivative and put it equal to 0, for that's the knowledge of the turning point. And once you got the 2 x's, you still need to get the 2 y's. This was not so nice because it worked out to very irrational answers that you rounded off, but that's fine. Whether it works out to nice whole number answers or to horrible, long, irrational, rounded off numbers, it doesn't matter. Okay.